Right, so let's start. Um, Thank you all for coming. I hope you will enjoy my presentation here today on µCon. So since we're on microservices, today we're going to talk about a big topic, which is, I think, a big part of microservices is the deployment process. Um, Everyone has services, everyone needs their services to basically run all the time, no downtime, to be scalable, up and down, whenever they need to. So today I'm going to give basically three examples, three use cases of how you can deploy your services on AWS. So my name is Josh. I'm a consultant, a senior architect in DevOps Pro. We're a consultancy working with companies, enterprises, and startups on their DevOps needs. Most of our challenges basically are the scale-up process. This is the part that most companies find it difficult, usually because their applications are not adapted, their data sources, their data stores are not well equipped with scaling up. So this is the stage they come to us and we help them with their challenges. So as I said, three use cases, and now I'm hoping we will have the time to show the third use case, which is Elastic Beanstalk. I want to show you a small presentation of how to create an environment and how to deploy that to that environment. So we're going to touch three services. The first one, all of them are part of Amazon compute services, which means they basically bring you servers in some form to have your application run on it and work on it. So today we're going to touch three of them. The first one is going to be ECS, which is Amazon Elastic Container Service. Basically, ECS allows you to run your Docker, currently only Docker, containers on Amazon in a scalable way. The second one is a new buzzword, not so new, but starting to catch up, which is serverless. And serverless is done in AWS using AWS Lambda and AWS API Gateway. And the last one is Elastic Beanstalk. Elastic Beanstalk is Amazon PaaS, which means they provide you everything from the platform side, the hardware, just bring your application and run it. And hopefully, as I said, we will have time to show the creation of Elastic Beanstalk environment and deploying a small node application onto it automatically. So let's start. Applications throughout the years have changed a lot. From the early 2000s, everyone had monoliths. They liked it. It scaled. Today, the scale is much, much higher. So applications need to be distributed. That's why there is the concept of microservices. So that services can scale up more quickly, and different services have different load demands. So today, we have many IoT devices or many services, so the load is very, very high with many companies. So applications are changing and moving into the microservices world, which is a distributed world. And each of these services needs its own process. Either it's a CI process, which is continuous integration. Each and every one of these services has its own tests. And more importantly, each and every one of these services has its own deployment and scale up or scale down process. It's individual to every process because different languages has different demands, whether it's memory, whether it's CPU. There are so many variables that need to be taken into account. So just a small, common application. Basically, we have the user goes into CloudFront, which is the CDN. Behind the CDN, we have the load balancer. We have a couple of servers. They can be web front end. They can be application servers. They can be cache servers, whatever you want. Afterwards, there's another load balancer, maybe if we have high security demands, and another application servers or worker servers or whatever you think of. And in the back usually is the data store, which is the database. So some of the content can be static, some of the content can be dynamic, depending on the service we're running. So today's challenge is never to say again, but it works on my computer. Your code doesn't need to work only on your computer, it should work on all computers, whether it's Linux, whether it's Windows. So we have a lot of challenges. We have lots of types of applications, whether it's static, it's user data that we're expecting to get. It can be a web front end, which is dynamic front end. We have lots of workers today because we want to offload all of the data coming from the user. We usually want to offload it to a background process because it can take time. I don't want it synchronized. We have a lot of applications that deal with analytics. Analytics are very heavy with data. So we need to manage all of these, and they all need to run on all environments, whether it's local, whether it's staging, QA, UAT, whatever you call it, production, everything needs to run. This is a very, very big challenge. And these challenges can be addressed in many ways. I'm going to talk about one specific way, and it's Docker. I will show today an application running inside of Docker, a small Node.js application running inside of Docker. Why did I choose Docker to work with? I've been working with Docker for over 2 years. It's a stable product mostly, in not the latest versions, a couple back, and it works very well. It allows me to have greater portability of my applications. I can move one file and deploy that file wherever Docker runs. Whether it's Windows, whether it's Linux, I can run my Docker containers. And that Docker solves all of these problems because all the applications, all my services, when they're inside of a Docker image, the Docker image contains all the dependencies. There are no outside dependencies. If I have Node.js, I don't need to install Node.js on my server. It's already inside of the Docker container, the Docker image. So now when we say it will run everywhere, it will run everywhere. Because all I need is one file, which is the Docker image. I just move it between servers, between people, and it runs. Just Docker run, and it runs. So we're not here to talk about Docker. Just a preview because I want to touch it later on. So the first topic in AWS we're going to talk about is Lambda and API Gateway, which is the serverless way of Amazon. So Lambda, what Lambda gives us? Lambda gives us is the serverless platform inside of Amazon, as we said, compute. It brings us stateless, only stateless. We cannot save any state, or we don't want to save any state in any data source. And Lambda is invoked by triggers. A trigger can be anything from HTTP endpoint to S3 new file, to SNS received email, to SNS received SMS. Anything inside of Amazon can trigger a Lambda function. The most common ones, the triggers, are usually API Gateway, when we want to have an API in front of Lambda, and Lambda do the processing and the compute. We put on API Gateway in front of it, and this is the use case I'm talking about. But there are many, many, many more use cases. For example, if I want to do video processing, I don't want to have a server up and running all the time, just waiting. Usually it's ideal 90% of the time. I just have a Lambda function, and every time I upload a file to S3 bucket, Lambda is triggered, and the file is being processed, and I do whatever I want with it. I corp, I do whatever I want with it. So Lambda. Why do we want Lambda? It's not just a buzzword. It really, really works. First of all, there's no infrastructure. Well, not that we control anyway. Of course, the code runs somewhere. But we don't manage that somewhere, which means that if we suddenly get DDoS, for example, the service will not fail because we have Lambda. Because Lambda will scale up as needed, and it will scale down as needed. It has enough compute power. You define the memory that you need to use, and it's all done for you. So all you need to do is write good code, which is hard, but that's all you need to do. The second reason, it's part of no infrastructure, which is high performance at any scale, which is basically the same. No infrastructure, they take care of everything. They're auto-scaling groups, and they do everything for you. So just bring your own code. Lambda currently supports only 3 languages, which is Java, Python, and Node.js. How many Java developers are there here? Good. Has anyone tried it? Tried the service? Yeah? Good. We have a couple of people. All right, so basically how Lambda works. There's the source of data, which can be, as I said, S3, SNS, API gateway, DynamoDB, whatever you can think of. The source of data just being attached to a Lambda function and just triggers it every time there is an event in that source of data. And that's all. That Lambda function does whatever you tell it to. That's everything Lambda. Really, everything. So Lambda is very simple service, as you heard, as I described, and there's a pricing model. There's a model of resource. Basically, every function that you create, you should give it a limit of memory, limit of basically, I think that's it, and a time limit and a time constraint, because usually you don't want the function to run forever. There's a time limit that after that time limit, the function just stops, just kill the process. And Lambda pricing model is based on memory and time. So if you're running a Java application, I'm sorry for you, because it takes a lot of memory and Lambda needs to use all that memory. If you're running Node.js, you're in luck, because there's not a lot of memory Lambda needs for Node.js. So the memory constraint is a lot smaller in Node.js compared with Java, but the time constraint can be significant. So depending on your application that you're running in Lambda, that's how I would describe the pricing, whether it's worth it or not. As I said, Lambda supports a lot of invocation types. It can be a database like DynamoDB. It can be SNS. SNS is Amazon service for emails and SMSs, I think, maybe. And these type of sources are very important to your application, because Lambda can run not only front-end application or being invoked by API gateway, but it can be invoked by different servers. So if I want to invoke it, actually I can invoke it with an API call. Every time I want something is done, something is happening in my application, I can invoke a Lambda function to do something. So Lambda is not limited by any trigger. You can trigger it whenever you need to. And a big plus of Lambda, it's very coupled with Amazon IAM service. IAM service is the identity management of Amazon. Basically, a Lambda function to be able to run, to be able to be invoked, to be able to access other Amazon servers or services, it needs to have a role. And that role in Amazon, it's in the IAM, the identity management, and that role specifies what that Lambda function can do. If it can access DynamoDB, she's checking for permissions there. So your application is very, very secure. If someone, for some reason, been able to to override your security and it's trying to access RDS, but that Lambda function doesn't have any permission in RDS, it won't be able to access it. This is a very, very big plus that helps you secure applications. Right, so how do we write functions? How do we deploy them? Lambda is very, very easy because all you need to provide is basically a zip file with your code inside of it and just upload it in 3 ways. As I said, Node.js, Java, or Python. You keep all the libraries you need inside the zip file. Lambda takes the zip, extracts it, deploys it to wherever it needs to deploy it, we don't know where, and just runs it. So you can upload the zip file through the console, which is highly not recommended. There should be an automated process that does testing first. So usually what I do, I post to Amazon API with the zip. If it's a big zip, you need to upload it to S3 first, and then Lambda takes it from there and deploy your application. Now, deployment process in Lambda can take time depending on the load, on the scale that you have. If it's a small scale function that doesn't take many requests, the deployment will be quick. If it's a big scale application, because it's a no downtime deployment, it basically creates new services and then removes the old ones. So your application is always running, is always getting requests, and the code is changed. So, so when we're talking about Lambda, we have to think stateless, because everything we do is not saved in memory, ever. Lambda doesn't save any memory. We always have to work with outside sources, whether it's input sources or output sources. If I have an HTTP endpoint that needs to change the password of the user, then Lambda gets the input from the data source, and outputs to a database. It's just the bridge. It's stateless. Whenever the transaction is done, nothing is saved in Lambda. There's no session, there's nothing like that. This is very, very important when we're working with Lambda. It has its benefits, it has its drawback, but in overall, Lambda works. A big part also working with Lambda is debugging. Debugging and logging doesn't come easy with Lambda, sadly. Not yet, anyway. So the way we debug is through the logs. We just write console log, if it's Node.js, print in Java, and basically it prints to CloudWatch logs, and then we just see the output. That's the way it works. It's not perfect. We can work with other third-party services, but it will take a bit longer because CloudWatch is inside of Amazon, so it's quicker. Generally, the way I use Lambda is with small functions, usually with not so much load. We've tried it with a lot of load functions. Sometimes it can be very, very pricey. I know everyone is saying that Lambda is cheap. It's cheap in certain circumstances, very, very certain circumstances. But it's a good service. I recommend just try everything once at least, and this is one of the things I do recommend trying, because it can be very, very fast. For example, we have a service that gets a very small analytics call and just outputs it to Redis, and the thing takes like 3 milliseconds, which basically means we're losing money because Lambda is minimum is 100 milliseconds pricing. If they would have priced us by a millisecond, then we would have earned more. So that's what I meant when I said it can be pricey. If I have a service that runs in 3 milliseconds, the minimum paying that I'm paying is for 100 milliseconds, I'm losing. So just going over it again, how to invoke a function. we can call from a web application, a mobile application, through usually API gateway, and wait for the response, which is synchronous call. Lambda does something, goes to the database, fetches the data and return it like a normal service. That's one way. We can push events into Lambda, which means if a file is uploaded to S3, a trigger is happening, and we get a JSON from S3 stating the bucket name, stating the file name, and all the other metadata that S3 gives us. As you can see, there are 3 tries, if it's working, if it's not. We can also have pull events, like from DynamoDB. If it changes from Kinesis, it's Amazon data pipeline service, and more. So it's a bit more about the invocation process, how it works, how the IAM are keeping us safe from Lambda, from accessing other servers, other services. So resource policies, which is an IAM role, we define which policies that Lambda function can access to and touch. Even inside of DynamoDB, we can define specific database inside of it, specific table, and that way Lambda can have access only to what we give it and nothing more. This is very, very important, because usually when we're working with a normal application, there isn't any kind of constraint. Basically, if we're good developers, we will have a different MySQL or Postgres or whatever user that has specific role. For example, it won't be able to create new databases, that specific role, because we don't want to give it access. Usually the way we do, we just give it root and we forget about it. So here we have the constraint that we have to define the policy to Lambda, the policy that it needs to follow. And if it won't, it just won't work. We will get errors, which is, to my opinion, a very big plus of using Amazon. All right. Coupled in our specific use case with Lambda is the API gateway service. Well, the API gateway service is also serverless, because we don't know on which servers it runs. It brings us a RESTful endpoint to all of our application endpoints that we want to expose, of course. And it's a bridge between our users to our backend. You can think of API gateway as HA proxy that just proxies request based on path, based on headers, based on authorization. API gateway can remove a lot of the things that we do in applications today, like authentication. API gateway can connect directly to AWS Cognito, which is an authentication service of Amazon, which means I can have my users not saved in my database, but in Amazon database. And every time there's a request from the user, it first gets authenticated, making sure it's a valid user inside Cognito, and only then the request is being transferred to my backend, which means it's a DDoS protection system if my service is not open to everyone. So why do we need API gateway? As I said, it defines our APIs and the backend calls that these API calls will do. It manages the deployments. We can have multiple environments based on that endpoints. It gives us protection in the form of DDoS attacks. It can just throttle a lot of the requests, just remove them. If we see a valid DDoS attack coming to our servers, we can identify it very quickly and we can block it in Lambda. We don't need to block it in our servers. We don't need to block it in our application. We can block it directly in Lambda. Lambda is being configured using a Swagger file. Is anyone using Swagger? Good. Swagger is basically a definition of APIs. Every endpoint you have, you write it inside of a Swagger file, and you just add labels and metadata, and you just upload it to API Gateway, and API Gateway deploys everything for you automatically, which means the Swagger file is in your code repository. If you need to change anything, there should also be a deploy process for that Swagger file into API Gateway. And the third reason why we need it is because it's also coupled with the IAM service of Amazon, which means if we want to block users, if we want to make sure the user is valid, we do the authentication process right here. We do the authentication process, and we don't need anything more. This authentication process, if I'm removing it from my application, it will save me, I think, 50% of the time in the first month of the application. Usually, the authentication process, when you write it down with a new application, takes a lot of time. I think everyone knows it. Yeah. So this can help us remove that and never think of it again, because it's done for us. And AWS Cognito has, I think, 50,000 free users, and only after that you start paying for it, this is very cheap, actually, and not really Amazon's way. Right, so API Gateway, we host multiple environments, multiple stages for our API. We're working with staging environment. We have an API Gateway configuration for staging. We have an API Gateway configuration for development. Every environment we need. Authentication and authorizing API connections. It's done for us. API Gateway can be coupled with with Lambda service, which means if an API endpoint is coming to us, a request is coming to us, it will invoke a Lambda function that does something and return the response, and API Gateway will return the response to that client. It can also invoke other things, not only Lambda, but this is our use case today. So we can have a cache stored in API Gateway. If we have a request that comes a lot of time but doesn't change often, we don't want it to touch our backend. We just cache it for a couple of minutes, a couple of hours in API Gateway, and it's done for us. Reduced latency because it's a very fast service. Very fast service, and the latency that we're talking here, it's not between the client and API Gateway only. It's usually between API Gateway and our application. Because API Gateway is deployed in the same region as my backend servers, because they need to access the same network. So the latency between the API Gateway and my servers are very low, because they're on the same region, usually on the same availability zone. Right? Everyone knows what the region and availability zone, right? Good. Right, so we can do API Gateway calls from iOS. We can do it from Android and JavaScript. There are clients for that. As I talked about Swagger, Swagger is very good. Even if you're not using API Gateway, use Swagger to describe your API. You won't need any documentation other than that for your APIs. It can also mimic a request to your API. They have like a front end that reads the Swagger file and creates a front end that can send mock requests, which is very good. It helps with everything. In API Gateway, a part that I must say I haven't used, which is the data transformation. For example, if I can define specific headers to reach my applications, and I can whitelist only that specific headers. If other headers are coming, if someone is trying to do XSS or do some other vulnerability on my application, everything is blocked in API Gateway. I only get the valid ones. And usually, if someone is trying to do that and we see the headers, we can just drop the whole request. If we see headers that are not supposed to be there, we can drop the whole request. And API Gateway allows us to work when there is no backend. We can just define the response that we want back, whether it's 200, whether it's 503, whether it's JSON, whether it's XML. We can just define it in the Swagger file, because usually, well, optimistically, the backend developers should start the work before the front end. It never happens, I know, but it should be like that. Why? Because we want the front end to have something to work with. So in this case, we don't have to. They start at the same time. They define a protocol, and we just put the protocol in the Swagger file, and the front-end guys has something to work with that mimics the request of the backend. When the backend is ready, just remove the mocking, and hopefully it will work. No promises. Right, that was Lambda. Before moving into ECS, questions? Good. Yeah.
Question.
Yes.
Question about monitoring and alerting. So you said that like Lambda is trying 3 times.
Yeah.
Like how do you detect that?
Well, you need to define it first, and if it fails, you can define if it's failed or not, depending on the response it's bringing back.
Are you define that in Lambda and you get configuration, or are you using another?
Yeah, in Lambda you can configure it. Usually it's timeouts. It's either you didn't give it enough time, or well, that's usually the timeout. Yeah.
What would the guideline be around like the size of a lambda? So given 2 things you mentioned, one the costing, so you probably don't want to make the lambda too small, but you overcharge. Also, I'm assuming maybe the operational overhead of maintaining these lambdas if you make the price. So in your experience with the guideline,
Well, okay. The question here was how big the lambda should be, basically. I've been dealing with these questions all the time because people think that they can have an AngularJS application and they can just transform it to Lambda or React application. To my opinion, Lambda is good for small things. And there are lots of small things, lots of small things. You can break up, not an Angular application, but you can break up a lot of endpoints from your application to Lambda functions. I usually recommend applications that need to access directly something inside of Amazon, not your own database, something inside of Amazon. If you're using with DynamoDB, then you can use Lambda. If you're using RDS, also. Only if you're using AWS services. And usually, the Lambda function should do one thing, just one thing. So I think the best use cases for that are any type of analytics, which is because analytics takes more time to process because it's usually a big chunk of data, I would use Lambda for it. That's my best use case. I must say I'm not the biggest fan of serverless these days. I think it's a bit young service. There are lots more work to do, and it's not for everyone. Any more questions? Oh, right. Yeah. Yeah.
API gateway versus Mashery or APG or something like that.
API gateways provide a lock. You're locked to AWS.
Okay.
Doesn't work with anything else. Good? Answers your question? That's it. That's it. That's the only reason to consider. Right? Yeah.
Right. I want to just do authentication API gateway, but want to defer the authorization to my backend service. Is it possible to
Yeah.
pass some sort of token?
Yeah. Cognito basically, when it saves the user inside of his database, there is a user ID. And you define that user ID to come to your backend services, and you just save that user ID with the authorization you like. That's it. Okay? All right, I'll move on. So ECS. ECS is Amazon Container Service. Containers has been up like from the 70s, I think, but in a very poorly fashion. And thank God for Docker in the past 2.5, 3 years, which helped us use it much, much better. So ECS came from the Docker movement. So we'll be able, sorry, how much time? 10? All right. So I'll move faster. So ECS, running Docker. ECS is consisted from a task definition, a service definition, and a scheduler. All of these combined are being deployed to EC2 instances that are managed by ECS. So ECS cluster, it can be several servers, EC2 nodes. They can scale up, scale down, usually using auto-scaling groups that control it. Servers should be in auto-scaling, as I said. Each server runs an ECS agent that manages it. I know, I'm very, very late. So in order to run Docker containers, we create an ECS task with the definition of that containers inside of it that we want to run on the servers. So basically, the task definition, from it, we create a service definition. A service can consist from a couple of containers. For example, if we have a WordPress service and it has a database and it has a maybe files container and the code container. So we can have 3 containers. All of them are consisted from the service is consisted from these 3 tasks that we tell him to deploy. And the scheduler. Basically, the scheduler takes care of everything for us. If we're doing an update of the application, if we're doing a deployment, if we need to bring up more services, if we need to bring down less services or servers, nodes. It takes care of everything. We can define rules in auto-scaling. This is auto-scaling, not ECS bounded. We can define rules that if a server doesn't respond to a health check, it will drop it. And ECS scheduler, we bring up a new one. This is very, very good. We don't need to worry about it. You can associate an ALB, which is an application load balancer, and an ELB, which is the classic version of Elastic Load Balancer, with ECS. It's not you can. I made a mistake there. You should, unless you have a service discovery that register the containers and knows how to handle traffic. If you don't have it, which most people don't have it, use it. That's where it's there. ELB or ALB. So, very quickly, ECS is a safe way to bringing your microservices inside of containers to production and above and beyond. The thing with microservices, we want them to scale, and this service can do it very, very good for you. It has a pros and it has its drawback. Its most notable drawback is that it takes a lot of time to configure it to be automatic, fully automatic. And if we want to do changes, we need to change a couple of files, as you can see. But there is but it gives us a lot of control, this service. Gives us a lot of control, and depending on our application, if we want more control, if we want to be more flexible, this is the service I would use. Usually this is not the case. Because our applications are simple, if you're writing your microservices right, they should be simple, they should be deployed on a generic environment. Doesn't have to be specific. Because usually with ECS, I build specific environment. Sorry, no questions. So, Elastic Beanstalk, our last and my preferable from all 3 of them. Why my preferable? Because I've been using it for, I think, the past 1.5 years, since almost it started, when it was shit, and now it's very, very good. I was being, gentle, really. So it's AWS PaaS service. PaaS means platform as a service, which means it brings up everything we need for our environment, and we should just bring our code to that environment, and it will scale up and it will scale down. So, as I said, it's the simplest and most intuitive way to deploy your application. This should really be your default. If you don't have a default, keep that in mind, use it. It's very, very easy. It doesn't take a lot of configuration. You can bring up new services in, I think, an hour. Usually today it takes me an hour with this service to have a scalable to infinity almost, depending on the backend, the data store, to bring up a service. So, why use Elastic Beanstalk versus something else? So usually everything, you bring up your code, usually there's a web server that needs to run your interpreter, and there's an application server and the interpreter that runs your code. Afterwards, there's the operating system and the host. Elastic Beanstalk takes care of everything for you. Just bring your code. That's all you need to do. It brings out all the components. When you scale up, you usually need a load balancer because you have multiple servers. It gives you ELB. You need auto-scaling group because you have a trigger that says if CPU is above 60%, bring up more servers. So it creates the auto-scaling group for you. It can create the database with the replications for you. Also, of course, it's optional, but it can do it for you. It can send log to CloudWatch. It can send SNS alerts when the environment has changed. If you've done deployments and, I don't know, the product manager or the project manager or the CEO wants to know about it, telling him that there is a new version up in the air, we can send SMSs when something changes. So, we said just your code. You create an environment inside of a region in Amazon. All regions are supported. You choose the stack type, which can be Docker, can be Go, can be PHP, Node.js, Java, and even .NET. So if you have an application, it can work. You don't need Docker to use it. You can just deploy your Node.js inside of a zip. It will open it and run it for you very, very easily. Right. So manage infrastructure. I've talked about it because I want to move fast because I want to show you the example. Hopefully I have another couple of minutes. So Elastic Beanstalk, it can be a web tier and a worker tier. Basically, a worker tier means it connects to Amazon SQS, which is the queuing service for them. And every time there's something in the queue, it will send it to the server and just run the process inside of it. So it doesn't have to be web. It can be also a background service. And managed, it means it will bring up more load balancers, more servers, and it will drop them when load is down. The process is very simple, as you can see. I'm dropping the whole build process right now, but this is a small Ruby application that just returns a hello world. Usually we push it to Git. Afterwards, there's the build process, which I totally ignored from it right now. But usually what it does, it tests your code. It makes sure the tests are passing. It prepares the zip file and just uploads it to S3. Afterwards, we create an Elastic Beanstalk application version, which basically means one file, and just take it from S3. That's it. Afterwards, we initiate the deployment, which can be done automatically or manually. If you're not safe, if you don't have tests usually, and you don't want to deploy your application right away, usually you do the checks on a different environment, and only then you move it into production, so the deployment is done manually or one button click. So the big plus in Elastic Beanstalk, because it's managed, everyone thinks we don't have any control of the environment. We have full control of the environment inside of Elastic Beanstalk. In Elastic Beanstalk, we have the files which are called EB extensions. These files are like CloudFormation. Has anyone heard of CloudFormation? Good. They're like CloudFormation. CloudFormation allows us to write JSON, and 2 weeks ago they added YAML to configure everything inside of AWS. If we want Lambda, if we want RDS, if we want the load balancer to have an health point called whatever, we can configure everything inside CloudFormation. And EB extensions are CloudFormation plus host commands, which means Elastic Beanstalk uses Amazon Linux for its EC2 instances. So we can install packages. Instead of doing yum install, we just write the package we want, and it's being installed for us, like Chef or Puppet. We can define groups or users. We can do files. This is actually an example. Here I create a file called limitsconf, and I upgrade the limits because it's a WebSocket application. And it should need to handle a lot of connections. So I want to have a lot of open files. So this creates the files, and this updates the kernel. This is another example of basically configuring the auto-scaling group. Tell him to the ELB check should have a grace period of, I think 3,000 seconds, which means, or 3,600 seconds, which means I'm giving grace period for the server. Since it's not responding, I'm giving it 1 hour, and then I'm going to kill it. Usually it's a lot of time. I usually do it like 5 minutes. I give him grace time, but I give him an hour there. All right, so let's see the deployment. If you have any questions until I'm running it, feel free. Good. All right. Okay. So this is Elastic Beanstalk. We're going to create an environment right now. So I'm going to select a platform. Usually my preferred platform is multi-container Docker. I can run 1 container per server. I can run multiple containers per server. Usually when I need multiple containers, I have the application container or multiple applications. If they don't have a lot of load, I just put several applications on the same server, and I just have a reverse proxy like Nginx to direct traffic between them. That's it. But usually I put on also containers for analytics, for metrics collection, and things like that. So it's very, very comfortable working with Docker. Oh, shit. No. Sorry. We're going to go. It's not coming back. No luck.
Can you disconnect and connect it? It takes like 2 or 3 minutes.
Oh.
You know, so
Yeah.
just let it. It's gonna come in a couple of minutes.
Okay. So it's going to take a couple of minutes. And, oh, yeah.
Give it us.
All right. So questions? No? I'm trying. Come on. So, okay, I'll describe what I will show you. Basically, we're going to create a new environment in Elastic Beanstalk. The way environments are created, there is a high level of application, and from application, I create environments. Because we have an application called, what's it going to called? Oh, crap. All right, so I'm going to create a new application, and the application name is going to be no test. And inside of that application, I'm going to create a web server with a multi-container Docker, load balancing, which it means auto-scaling. It will bring up nodes whenever needed. I'm just going to tell him use a sample application at the first deployment, and then I'm going to do a deployment myself. And it's going to ask me about the deployment process, which can be, you can define how many servers at the same time you want. It can be based on health, on time, whatever. So I'm going to give the environment a name. I'm going to give it prod node test. It's going to create an environment URL for me, which is unique. I'm going to check the availability, and I'm going to do next. I don't need any RDS, and run it inside of VPC. So I'm giving an instance type, whatever, key pair, email, it's optional. I think everything else is optional. All right. It's going to create roles, IAM roles for the servers. So if I want my servers to be able to access any other Amazon services, I just put the policy in the role, and they will be able to access whatever it's needed. So now it's going to create the environment. I want to quickly show you the configuration files. No, sorry. All right. So the configuration file is basically very small right now. The configuration file, it's a Docker run file that basically defines the Docker containers for that service. So I'm just giving it a name. I'm telling him which Docker image to use, and the tag is basically the version number of that image. And I'm giving him environment variables. So the environment will be production. For example, it's a production environment. Sorry. I'm giving it a memory limit. Every container needs to have a memory limit. And I'm telling him which ports to open and to map. So I'm telling him to map port 3000 inside the container to port 80 on the server. So that when the load balancer will want to reach, I know, sorry. So if you have any more questions or want to continue to see the demo, I'm sorry I didn't make it. Just feel free to contact me. Thank you.